Hello and good day, geometry. We are starting officially geometric proofs. It's the last objective of unit. It's at least a 3-day extravaganza, and so we'll be on it for a little bit here, but expect a test before things can break on unit 2. We still have like 7 days before things can break. We have a lot of time. Okay, so writing a proof. It'll be a try 2 grade, yes. Proofs are all about answering 2 questions. Okay? The first question is, what do I know? Okay? The first question when answering a proof is when writing a proof is what do I know? Okay? And that's where the given statement comes in, right? This is where you look at the given statement or what's marked in the diagram or whatever, and that's why every proof starts with that given statement. What do you know? What are you told? Okay? And then the second question when writing a proof is what can I conclude? Okay? And that's where you're using the properties, the postulates, the theorems, all those sorts of things that we've been learning, slowly building in our toolbox here, because you can make conclusions about the diagrams based on relationships. That's why relationships in geometry are so important, and to recognize what those are. Okay? Writing a geometric proof uses definitions, properties, postulates, theorems. The more of these you know, the easier writing proofs will be. It's kind of like if you are doing a home improvement project and the only tools you have are a hammer and a screwdriver. Okay? You're going to have a much tougher go at it than if you have a hammer, a screwdriver, a drill, and lots of other tools that exist. A wrench, blowtorch,
a nail.
A nail, right? The more tools you have, the more success you are going to have as well. Okay? So these are all things today that can go on a help sheet. As you're building your help sheet from unit to unit, put these on there. This one I want you to star. I had you star the substitution property the other day also. This is one that's used a lot. Okay? It's the reflexive property. And it's used primarily for segments and angles. Basically, in segments, segment AB is equal to itself.
Cool.
Yep. It's like if you hold something up to a mirror and you see the reflection and you see exactly what's presented in front of it, that's kind of what this is here. Okay? For angles,
How'd you come up with these?
This is a waste of my time.
the reflexive property says angle A is equal to
Angle A?
itself.
Whoa.
This is wonderful.
You said that?
This is a waste of my
I've never done
time.
this before.
I didn't know
Using
this.
variables,
How is this key?
A is equal to itself. That's the reflexive property. Okay? Something is equal to itself. It seems very, very, I don't know, what's the word? Elementary, stupid even, okay?
I thought A equals
Shh,
12.
I didn't talk to you. But, I'm going to put that in my recommendation. We are going to be using this pretty often when we compare triangles, when we figure out if triangles are congruent or not. Any shared side between 2 triangles or shared angle, that's what the reflexive property is used for. So it seems stupid because it's so easy, but it's going to be an important one. We'll use it often. The symmetric property, if there's one you want to call stupid, it's the symmetric property. The symmetric property basically says, and I'm going to use it in variables and values, but it says that if, this is a sample, if x equals 5, then 5 equals x.
Oh, nice.
That looks like an S. I shouldn't use 5. You can use whatever number you want to. It doesn't look we'll say 10. If x equals 10, then 10 equals x.
So does that mean X equals 10?
If x equals 10, then 10 equals x. Not every, oh, Roman numerals. I like that. That's not where you're going?
No.
Oh, well, that's what you just went there. Yes, in Roman numerals, x is 10. So, good job. Take credit for that one. So the reason why this one exists, what?
You mean me to star this? You
No.
said it's stupid.
Oh, here. If it gets 2 stars, that means it's stupid. So put 2 stars. Okay. The reason why this one exists, if you are given, and I'm just going to do a very simple equation here, x plus 7 equals 15, and you are told to prove that 8 equals x. Okay? Now when you go through solving this, what are you going to do to solve this equation?
Subtract 7.
Subtract 7, and what will you get? You'll get x equals 8. Right? If you subtract 7 from both sides here, you'll get x equals 8 because x starts on the left side, subtract 7, you get x equals 8. However, if you're told to prove that 8 equals x and you prove that x equals 8, you have not finished the proof yet. Because your proven statement needs to be exactly what you were told to prove. So your last step here, you'd actually have to do an extra step. You'd have to reverse this, and your reason for it would be the symmetric property. See why it's dumb? But geometric proofs have to be so specific and so clear that if you're told to prove that 8 equals x and you prove that x equals 8, you do need to do an extra step to flip that around so it matches exactly what the proven statement is.
I think the other one is stupider.
I think they both are.
Okay.
It's like, I think like
I think we could just skip this.
The transit property, only 1 star for this. This one's not stupid and you'll use it often.
We'll see.
You will. Okay. We've actually used this one before in algebra when we proved that any base to 0 power is 1. Okay. Well, the transit property says that if A equals B and B equals C, then A equals C. So the transit property involves 3 things. If the first thing is equal to the second thing, and the second thing is equal to the third thing, the first thing has to equal to the third thing.
Double star.
Okay? Yes?
Why is parentheses, segments, and angles like on the?
Because that's when you'll use it a lot. You'll use it with segments and angles. Don't worry about that right now. I showed you kind of all 3 here, but don't worry about it going forward. Okay? Gus?
What was an example we would use a reflexive property?
The reflexive property, if you wanted to prove that 2 triangles were congruent, and you had something like this, okay, where this is A, this is B, this is C, and this is D. I'm not going to get too far into it right now because there's a whole bunch of theorems, side, angle, etc. we have to talk about yet. But if you were to prove these 2 triangles are congruent, you could say that segment AD is congruent to segment AD. Because AD is 1 segment, but it's part of both triangles. And so when proving triangles are congruent, you're trying to get 3 pairs of corresponding parts to be congruent. One of those corresponding parts could be this shared side, but you have to name it. You have to name it. This is one of the 3 corresponding parts. Okay. So there's your thing. Okay. Questions on the reflexive, symmetric, or transitive properties? No? Very well. The right angles congruence theorem says that all right angles are congruent. The right angles congruence theorem states that all right angles are congruent. Because all right angles have the same measure, which is 90 degrees.
It's like triple star.
No, this is no stars.
This is the same as the first one, the reflexive.
Kind of. Kind
Yeah,
of.
it is.
Kind of, yes.
But it's the right angles congruence theorem.
Yeah.
Yeah, so much more.
You could say the 35-degree angle congruence theorem, I mean, so.
The congruent supplements theorem states that two angles that are both supplementary to the same angle are congruent. And I'll draw you a nice little picture to help with this one. Two angles that are both supplementary to the same angle are congruent. So, for example, if we had a line here with two angles, we'll say this one is 130 degrees there. Okay? Then we have another angle somewhere over here that we'll say is 50 degrees there. Even without any angle measures, I can conclude that these angles are congruent. How?
Because they equal 180.
Because they're both supplementary to the same angle. We know that our two labeled angles are supplementary because we can add 130 and 50 together to get 180. How do we know that this unmarked angle is supplementary to our 130 degree angle?
Because you need 180 degrees to, like, finish that.
To make a line, right? Two angles make a line. It has to be 180 degrees. That has to be 50. Okay? So there are two angles that are both supplementary to the same angle. Therefore, they are going to be congruent. Okay? The congruent complements theorem is kind of the same thing. Only replace the word supplementary with complementary. Two angles that are complementary to the same angle
Oh, too round. I think that's the wrong type of tube.
Huh?
Yeah, I think.
Oh, it is. Sorry. Oh man, that's embarrassing. Don't tell Spiel.
Well, it's in the video.
Oh boy.
Nice and swim.
This one might not be posted. Two angles that are complementary to the same angle.
I'm just gonna go through all your videos and then like make a mixtape.
Oh, this is the only one with a mistake ever. The only one.
Sure.
All others are perfect. Yep.
I think someone in our class would go for and find all the mistakes and then just show them the shoulders.
Do you know how long that would take to go through every video? You have to watch it like in its entirety.
Well,
I
I
just
just
pay attention.
Just double
And
speed.
pay attention, right. That's, yeah.
Double speed.
Ain't nobody got time for
Can
that.
I just like AI your voice?
Don't say
Just,
ain't
like,
nobody.
Start doing stuff?
Two angles that are complementary to the same angle are congruent. So similar thing, if you have a right angle, we'll say this comes up like that, and this is, we'll say 30 degrees there. It's not a bisector. If it was, it'd be 45 and 45. But if you got that, and then over here, you've got, let's have our angle. I rarely draw angles opening to the left. We'll draw it like that. That this is 60. Okay? Again, we can know without any labels on this other angle that these two angles are congruent, because in order to make that 90-degree right angle, this would have to be 60, and that's marked as 60. Therefore, they're both complementary to our 30-degree angle, and therefore are congruent. Questions on the congruent supplements or the congruent complements there? We won't use those too often, which makes it easy to forget.
Double star?
Not double star. Double stars. What was that one?
Stupid.
Double stars. Stupid. Stupid, and you don't use it often. These are not stupid. These are just things. The vertical angle congruence theorem says that vertical angles are congruent. We already knew that though, didn't we? Vertical angles are congruent. So if you have two intersecting segments, rays or lines, those vertical angles opposite each other at a vertex. You've got two sets of them. Okay? They are congruent. Star this one. This one is used a lot. And is not stupid. So 1 star.
Triple star.
No triple star for this. No, sir. Question on vertical angles. I don't know why I left so much space for this one, but whatever. Lastly, I think there's one more. Can I move down? Are we all good? Okay. Lastly, linear pair postulate says that two angles that form a linear pair sum to 180 degrees. Two angles that form a linear pair sum to 180 degrees. Okay? So again, we're talking about lines here. You can only have two angles in a linear pair. So the word pair and the word line are part of linear pair. That's why it's two angles that form a line. Right? But we know, even without measures, that they would sum to 180. So if this was labeled angle 1 and this was labeled angle 2, even if we don't know what those measures are, we do know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay? Even if we don't know what those measures are, we know that together they sum to 180. All right. Some other things that we've covered throughout our time together that are going to be used in proofs: the segment addition postulate, the definition of a midpoint, definition of an angle bisector, angle addition postulate, postulates 5 through 11, the properties of equality from CO15, addition, subtraction, multiplication, division, and the substitution property also from CO15. So our toolbox is getting pretty hefty. Okay? There's a lot of tools, a lot of reasons you could pull into that are going to help you with proofs. The key is knowing them. So we are going to start having postulate and theorems quizzes, okay, to where I will give you a theorem. Actually, I think I give you the definition or the meaning. You have to name it, right? So if I said on the Google form, two angles that form a linear pair sum to 180, you would select the linear pair postulate. Okay, what's that?
Let's do that
We're gonna have to know this
Yes.
by memory?
You're going to have to know this. You can use your binders.
Oh, okay. Oh.
Okay, but again, you only have 5 minutes to do it, so if you're constantly searching back and forth, you're gonna run out of time. Audrey,
Can you like redo it?
what?
Can you like redo the quiz?
Yes, just as always. It'll be
So
in
it's a
place.
bell ringer?
So instead of a bell ringer, we'll do these. So
Okay.
homework checks will still be homework checks, but bell ringers will become postulates and theorems quizzes. Yeah.
Like,
What are the tests gonna look like for this subject?
Exactly like what we're gonna do now. What part 2 is. No, actually no. I take that back. This one's gonna be matching. PO16 on the test is gonna be matching. We don't do actual proofs on tests until unit 3.
Like,
So
draw lines and match it?
pretty much. We ease in to it a little bit. You go.
Why is there like not an arrow on one line?
Oh, I don't know. I just laziness. All right, before we go, let's do a geometric proof. Here we have a situation. It says write a proof. Given angle 1 is congruent to angle 3, and we need to prove that angle 2 is congruent to angle 4. So again, those two questions, what do we know? We know that angle 1 is congruent to angle 3. That's how our proof is going to start. You're going to make your statement and reason chart. I recommend making your statement side a little bit bigger, just because you don't know exactly what you're going to need to write in there. But then you've got your reason there. And our first statement is what is given to us. Angle 1 is congruent to angle 3. And that is because it is given to us. Alright? And our job is to prove that angle 2 is congruent to angle 4. So it might help to mark in the diagram what you know, just if you're a more visual person. We know that 1 is congruent to 3, right? We want to prove that 2 is congruent to 4. Now,
Is it vertical angles?
here's what my advice is to you. Since we need angle 2 and angle 4 in our proving statement, we've got to figure out how can we introduce them to the proof? How can we invite them to the party? What's something we can say about angle 2 that puts it in the proof? Right? If these are part of our proving statement, we've got to get them in the proof to start with. What do we know about angle 2? Luca?
2 equals 4?
No, it's
Why?
congruent. It's congruent to what?
Alright.
How can you defend that 2 is congruent to 4?
Because 1
It was all unlocked.
is 1 congruent to 3?
Sure is.
Like, oh, yeah.
That's what was given to us. I heard it over here. Ella?
One is congruent to 2.
Okay.
3 is congruent to 4. So like. they're
Okay,
the
hold on.
same.
Whoa, not not fast. One at a time. Okay. Now, Ella introduced angle 2 to the proof by saying something we can conclude about angle 2. We can say that angle 1 is congruent to angle 2. Why can we say that? They're vertical angles, right? Angles 1 and 2 are opposite each other at a vertex. They are vertical angles. And she also went on to say that angle 3 is congruent to angle 4. And we can do these in the same step because they have the same reason. And you don't have to write vertical angles congruence theorem. You can just write vertical angles.
Can I have it?
Don't push it.
Can I put vert? Wait, can I put 4 verts?
Vert angle. What?
No.
Vert aim.
You're getting vert angle.
Vert angle.
Yeah, you're gonna put angle.
Okay. Step 3.
Give a little bit of this guy.
Right? Now ultimately we have to say that 2 is congruent to 4.
So then,
If 3 and 1 are equal and they're vertical angles, then 2 and 4 are technically equal.
4 equals
we
1.
know that, but we have to.
Transitive property, guys.
Well, we kind of have like 4 things going on here, right? We can't use the transit property with 4 things. We can only use the transit property with 3 things. So this is a property we haven't used yet, but we're going to use the substitution property. Okay? We know that angle 1 is congruent to angle 3, right? So wherever we see an angle 1, we're going to put in an angle 3 because those 2 things are the same. Therefore, they can be substituted for each other in any expression or equation. So our step 3 is going to be angle 3 is congruent to angle 2. We're taking this right here and we're rewriting it, substituting angle 3 in for angle 1. Because those of you that were saying the substitution or the transitive property earlier, the problem was we had 4 things, angles 1, 2, 3, and 4. By doing this and looking at these 2 statements right here, how many angles do we have? 3. And if angle 3 is the same as 4, and angle 3 is the same as 2,
There's a 1.
then 2 is the same as 4. That's the transitive property there. Okay? So to get there, we first did the substitution property to bring down the number of angles we were talking about from 4 to 3. So we could use the transitive property. So then to step 4 now, if 3 is congruent to 4 and 3 is also congruent to 2, that means that angle 2 is congruent to angle 4 because of the transitive property. And there you go, your first official geometric proof.
That's like the word
Okay. Transitive.
When can we leave?
When class is over,
But when's it over?
it's November 14th. You haven't figured that out by No, man, I can't help you. Like, we have this every day. Okay? Again, walking through the components here. What did we start with? What we knew, what was given. Okay? We then asked ourselves, how can we introduce angles 2 and 4 to the proof? If we need them as part of our proving statement, we've got to put them in there somehow. So we looked at angle 2 and we said, what do we know? We know that angle 2 is congruent to 1. We know that 4 is congruent to 3 because they're vertical angles. That introduced them to the proof. That was step 2. Then we have all this congruency, and a lot of you were saying transitive property, and you're right, but the transitive property can't be used with 4 things, only 3. So step 3 was substituting angle 3 in for angle 1 because they're the same, and that got us only 3 angles to work with here. 3 is congruent to 4, 3 is congruent to 2. Now we can use the transitive property to say that 2 is congruent to 4. Okay? This takes practice, right? Recognizing the relationships and how to put it all together takes practice. You've done 1. I'm not expecting you to be experts on proofs right now. Okay? But I hope you are seeing that you need to be able to recognize these relationships in order to have success. If you don't know what vertical angles are, you could not have solved this proof. Okay? Luca.
I remember saying 2 equals 4.
You did say that, Luca.
But I just don't feel like.
The answer isn't this. The answer is
All of it.
You have to flip it, don't you?
everything but that.
Yeah, because it already says that 2 equals 4.
How you get there, how you get to that is the answer.
Because it already
So-
says 2 equals 4.
Okay?
That's the whole point. It's called proof.
All right. Any other questions, comments, concerns, complaints,
This isn't homework.
compliments, congratulations, criticisms on this? MC, we're not leaving quite yet. You go. Go ahead.
You could say it just looks like it.
Yeah, there is no it looks like a theorem.
Lucas was a
Not,
conjecture.
that is not a thing. Aiden.
Uh,
Folks, shh. Hands up, floor.
About the quizzes, is there just one of them? Is just one
You'll have 5 theorems per quiz. James?
Don't you have to like flip it because of? Did you say we had to flip it?
If we had written 4 is congruent to 2, we have to flip it. And because we wrote 2 is congruent to 4, then we don't. Tegan?
Whoever said like, oh, let's make this or just make write everything. I don't have a thing for this, so like we're using it. Oh my gosh.
The logic behind this is the goal. The logic behind this is that when you go into a career, regardless of what it is, you'll have to problem solve. You'll have to say, what do I know, and how can I get to the solution? That's what we're after here, the logic behind it. That, regardless of any career. You want to know why the McDonald's ice cream machine is always broken? Because they don't have enough problem solvers. Fix it. You will fix the ice cream machine. All right, no homework tomorrow, except to your Khan Academy. That's how I'm at.